Hello everyone, welcome to my channel. And here we have today an exponential equation similar to one of those given at Oxford University interview questions. We have 2 to the power of x plus 4 to the power of x plus 8 to the power of x equals 39. And we're looking for the real values of x. So how do we solve this exponential equation? We normally have one or two terms on the left and on the right a constant. But here we have three terms on the left, all with exponent x. And do you notice anything that's related to each one of those bases of the terms on the left-hand side? 2, 4, 8, right? These are multiple of 2. So what can we do from here? So how do we solve this? All right, so let's start. What we're going to do here now as a first step is we make the base the same as base 2 on the first one, the leftmost term. Okay, so let's do that. So 2 to the power of x plus 4 can be written as 2 squared to the power of x. Third term, 8 can be written as 2 cubed to the power of x equals 39. So now, what do we see clearly on the board? We have the same base now, right? And what about the exponents? Exponent 2, exponent 3, and outside exponent we still have those x. And so from here, based on the exponent property, if we have a to the power of m raised to the power of n, we can write it the same way as a to the power of n raised to the power of m, right? What do you notice? Switching the exponents, right? And so we can do that on our equation. So we have 2 to the power of x plus 2 to the power of x. Second term, to the power of 2, plus the third term, 2 to the power of x to the power of 3 equals 39. And so now, what should we do from here? So we'll be using substitution, right? So now let's designate a variable that represent 2 to the power of x, and that variable is u. So let u be equal to 2 to the power of x, and let's use this variable into our equation. So we have u plus u squared plus u cubed equals 39. And from here I would like to rearrange the terms of the equation and put all these terms on the left hand side, and the right hand side will be 0. Well, it's starting from the left hand side with u cubed. Alright, u cubed plus u squared plus u minus 39 equals 0. And so now what do we see? A cubic equation, right? And so how do we solve a cubic equation? So here we're trying to find the factors of negative 39. So how do we do that? How do we find the factors? So let's write over here the factors of negative 39 will be plus or minus 1, plus or minus 3, plus or minus 13, plus or minus 39. And so at this stage, we're looking for the factor that's compatible into our equation, right? What does it mean by that? We're trying to find the first root of u, right? So u can be or any of these factors of 39, negative 39. So let's try first with positive or negative 1. Or let's say 1. If we plug in 1 in place of u over here, can we arrive at a 0 result on the right hand side of the equation? No, huh? What about 3? Plug in 3 over here. So 3 cubed is 27 plus 3 squared is 9. So 36 plus 3 is 39. And we subtract 39, so that makes 0, right? So we have positive 3 as the value of u. What about the other factor of this cubic equation. How do we find that? Well, let's do synthetic division or long division. In here, we'll be using the synthetic division. And so for synthetic division, we'll be using the coefficients of each term of our equation. The coefficient here is 1, second term is 1, third term is 1, and the last term, that is constant, negative 39. So we'll be using that for our base. So we have something like this. Coefficient of the first one is 1, second one is 1, third one is 1, and the last one is negative 39, constant. And here we put out the value of u, that's 3. So we have here bring down that 1, and then multiplying 3 times 1 is 3. And then we add these numbers. 1 plus 3 is 4. Then 3 times 4 is 12. Add 1 is 13. 13 times 3 is 39. Add this up, 0.
The remainder is 0.
And so now these numbers are the coefficients of each term of the resulting
second factor of our cubic equation.
And 1 corresponds to the coefficient of the first term on the left, that is for u squared. From u cubed earlier, we're going down to u squared. And on here, 4 coefficient of u, and 13, the positive 13, the constant.
The 0 on the right is the remainder.
The other factor from our cubic equation is u squared plus 4u plus 13. And now we equate this to 0. So we'll be looking for the roots of u, right? Or the values of u. Okay. So how do we do it? So from here, we can use the quadratic formula to find the value of u. So from our equation, quadratic equation, let's find the delta, or what we call the determinant, if this will be a real number or a complex number solution for u. So that is the square root of b squared, right? b squared. Since this is coefficient here is 1, that's A, 4 is B, and 13 is C. So under the radical sign, that's B squared, right? So B squared is 4. 4 squared minus 4A is 1. C is 13 times 13. So 4 squared is 16 minus 4 times 13, 12. So 52, right? So this will end up a negative value.
16 minus 52.
So this is negative 36. So that's the delta. This is an indicator that the value of u over here will be in a complex form because of the negative value. Since we're looking for the value of u as a real number or real solution, we're discarding this value of u.
That can be calculated from this determinant.
So we're rejecting this. Or we can say, since we're just selective in solving this equation, we're after the real solution or the real values of x.
But in reality, there are complex solutions to this equation. So in here,
we're using the value of u as 3. Let's recall that u is designated variable in place of 2 to the power of x. And we're using the value of u as 3. So now we have 2 to the power of x is equal to 3. So here we'll be using logarithm. So take the log on both sides of the equation. Log of 2 to the power of x equal to log of 3. We're putting down the exponent to the front as coefficient following logarithm property, logarithm power rule. If we have here logarithm of a to the power of b, this will be equal to b times logarithm of a. Putting down the exponent as a coefficient. Okay, so back to our equation. This is now x times log of 2 is equal to log of 3. Solving for x divided by log of 2 both sides of the equation. So this now cancels. So we have x is equal to log of 3 divided by log of 2. Or this is the same way written as log of 3 base 2. This is from the change of base formula. So let's say if we have here from the change of base formula log of 3 over log of 2, we can write it the same way as log of 3 base 2, right? And the bottom log of 2 can be written as logarithm of base 2 of 2. So this comes up to log base 2 of 3 divided by what's on the bottom? Log base 2 of 2, that's 1, right? Since a logarithm asks for what's the exponent of 2 to make it 2. The exponent of 2 here is 1, right? So this is 1. So we ended up with log base 2 of 3. So that's what we have over here. So our value of x is equal to log base 2 of 3. And here, by using our calculator, the approximate value of x here is approximately equal to 1.58. So now we need to check our answer value of x just to make sure we got the right answer value of x. So we have here our original equation, and we plug in this value of x in terms of logarithm, right? So 2 to the power of x, that is 2 to the power of logarithm base 2 of 3 plus 4 to the power of x is to the power of logarithm base 2 of 3 plus 8 to the power of log base 2 of 3. Is this equal to 39? So now we have here 2 to the power of log base 2 of 3. This one cancels. Ended up with having just 3. And here 4 to the power of log base 2 of 3. What should we do here? So we convert this 4 into base 2, right? So this is now equal to 2 to the power of 2 times logarithm base 2 of 3. It's the same way with 8. So this transforming it into base 2. So this is 2 cubed, right? 2 to the power of 3 to the power of log base 2 of 3. This is written the same way, 2 to the power of 2, like this. Or written the same way like this. But hey, that's the same thing. So 3 plus, here, we're multiplying the exponent. And here, 2 can be put as an exponent here. Right, the same thing on the 3. Let's do it clearly like this. So 2 will be going up as an exponent of 3. The same thing on here, 3 going up exponent of 3. So now we have the second term. You have 2 to the power of log base 2 of 3. And the exponent 2 came up as exponent of 3 right here. So that's 3 squared. Then plus 2 to the power of log base 2 of 3. Likewise on the 3, going as the exponent of 3 right here. Alright? Okay, so now simplify this further. So we have 3 plus 2 raised to the power of log base 2 of 3 squared. Log base 2 and 2 cancels. We have 3 squared, that is 9. Plus the third term, cancel this out. So we have 3 cubed, right? What is 3 cubed? 27. Okay. If we sum this up, will this be equal to 39? So the left hand side, 9 plus 3 is 12, plus 27 is 39. So 39 is equal to 39. So this simply means that the value of x that we found is correct. We have x is equal to log base 2 of 3, or approximately equal to 1.58. So this is now our final answer.
And so that's all for now. Thanks for watching, and for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. Feel free to share this video to your friends and classmates so they can learn this kind of technique as well. Alright, I will see you in the next one. Have a great day everyone. Take care. Bye-bye.